As I mentioned at the end of class on Wednesday, we have population, and then we have sampling, and we have a census, whether we're measuring everybody or just measuring some. And really, which is preferable when depends on what you think you're trying to measure and how you're measuring it, and then some information about the size of the group. If I have an effectively infinite population, this is page 32. If I have an effectively infinite population, production lines keep producing things. I will not tell you how many bottles of water were produced at the latest Pepsi factory today, but I don't want to test them all. Doesn't make sense. If testing destroys what I'm building, if I have to reopen all those bottles to test them, that's a problem. If I'm really going to do a continuous census of all of it, am I going to be able to get the information in time to make a decision? Will it be accurate sampling? Will it be efficient? Will it cost me? How sensitive is the information? On the other hand, if I don't have a big population, then I might be able to count them all easily. If the amount of sampling I need turns out to be a large fraction of the population anyway, if I'm going to end up sampling 75% of everybody, why not just do everybody? If I already have a database, if I want to talk to voters, I can actually look at the voter rolls. It's easier to get there. And if there are legal requirements for me to do that, I have to count out everybody's register at the end of the day at my store. That's a legal requirement. Then I might as well just do the full census rather than just count one register and assume everybody else was just as good. So let's describe the things we're trying to get information about. We usually denote our population size by capital N. And our sample size by little n. So n is either the number of things that are possible or the number of things we got, depending on whether it's uppercase or lowercase. Once I have information from my sample, I can get opinions on the information of the whole population. So in a population, we have descriptors. We usually call them parameters. So I can look at something and I can say, what am I measuring in this population? Average height, average cost, whatever. There are individual things, but that applies to everybody. Age, height. I'm thinking of numerical examples at the moment. Qualitatively, gender. I can code it, but it isn't necessarily easily described numerically. Usually, we'll use a Greek letter for a parameter. So we'll often talk about the average of something, and we'll use the Greek letter mu, lowercase m, for a mean. We'll use a proportion. 1/4 of the population has criteria X, whatever that is. But almost always, a population parameter is a Greek letter. But I'm not going to know that unless I've done a census. But I may be able to then take all that same information from my sample. In the same way that a parameter is a characteristic of the group, a statistic is a characteristic of that sample. Pi, a p, right? For proportion. I know it's a constant. Pi is 3.14. I didn't write this, and the statistics people use way too many letters in the same way that other people use them for other things. This is almost as bad as the science people. Ask any scientist what K is, and they might want to throw something at you. Ask a physicist what V is. There are 18 different V's. Context is going to be key here. In this course, pi is going to be a letter, not a number. So that's exactly the same definition. A statistic is a characteristic of our sample group. And the way we tell them apart is here we'll typically use quote unquote normal letters, Roman letters. So for our mean, we'll use a different symbol. An X with a bar on top of it. For our proportion, we'll use a P. I want to make sure that looks like a normal lowercase letter p. Advantage. If I've got a good sample that's representative of my population, those things should be close to each other. I should be able to say, oh, I took a good sample, it accurately represents the larger group. Deciding how to get that good sample is not obvious. Questions? Yes, sir.
So if you do the whole thing, characteristics are Greek letters. And if you do the sample, that's Roman. So
99.99% of the time. I will tell you there are regular events where, like if I'm doing a class, I've got all of you, right? So I'm thinking this is a population. But if I think of this class in terms of all the people who could be taking this course, not just this term, but in other terms, then you're a sample. So it's going to depend on which way I think of the group I'm working with. But yes, I will strive substantially to make sure that I use Roman letters for sample work and Greek letters for population work. The textbook absolutely is firm on that. Target population. I'm trying to find information out about a certain thing. I'm probably trying to find information out about a very specific question I want answered. If I'm asking a question about pregnancy, I don't think I'm going to ask the men very much about it. If I'm asking a question about prostate issues, I'm not going to ask the women very much about it, right? I'm going to ask people who have prostates or people who have uteruses about those respective ideas. So my target population is the group I'm interested in within my population. If I'm asking about a human resources class, it doesn't make sense for me to ask that question to the finance majors unless they took it as an elective, right? And I don't know if any of the human resource classes are electives for the finance major. I'm pretty sure they aren't. So when I go to take a sample, I need to aim correctly. And that means I have a sampling frame. Where should I aim to get my sample? Ideally, this matches my target population as close as I can get. But how do I get the sampling frame? How are you going to do your question? You're going to call people on the phone? You need a phone list, a directory of some type. You need a database of people who have already said they have your product, and therefore you can call them and ask questions about it. So you could go to the product registration database. You could go to the voter registration list, as I mentioned earlier. If I want to ask questions of high school students, it doesn't make a lot of sense for me to use the student directory here. Unless you all have younger siblings, and I know that for sure, right? So if I am thinking about Standard & Poor 500 stocks, if I say the average price earnings ratio for the entire S&P 500, is that a parameter or a statistic? Say again? Why? If it's the whole population, then the whole population's parameter, because I said the price earnings ratio average for all of the S&P 500. Now, if I'd asked you against the S&P 500 against the entire stock market, then it would be a sample. But if I'm looking at just the S&P 500, if I ask the proportion of stocks that had a negative earnings ratio last year, portion of the S&P 500. Well, if my target population is the S&P 500, that's a parameter. If my population is the entire stock market, it's a statistic. Notice the difference is my choice of target population. I can use the same number two different ways. By trying to measure it, if I'm just looking at S&P 500, then I've looked at everything. If I'm looking at the broader market, then I haven't. If I take 30 stocks and say, how many of these are energy stocks? Sample, statistic, or parameter. Took 30 of them. Regardless of whether I'm working from the list of 500 or the entire stock market, that's definitely not the whole group, is it? So that is going to be a statistic regardless. How do I pick 30? That's not a rhetorical question. I want you to think about ways in which you could get 30 stocks out of the list of the S&P 500. Okay, does that mean you take the first 30? I think Xerox will be really happy about that, right? They're never going to be on your list. Yes, I could work alphabetically. I absolutely could. So I could make a jump, absolutely. Certainly. I certainly can. So what we have at the moment are two different setups. We have deterministic ones, where there's a pattern to my selection process, and random ones. So let's address these differently because there are different pieces to the way we do random and non-random samples. So let's think about a random sample first. I have notes for random first. We'll start random. I need 30 out of 500, right? So how do I get my 30 choices out of the list of 500? What are you physically going to do? How? Seriously, that sounds like a really stupid question. How are you going to get your 30 random stocks? Pick a bin, put numbers from 1 to 500, and go, this is the list from 1 to 500. Number 73. May fortune be in your favor, whatever the whole line is from on. There. We can do it that way. Absolutely. We can do a complete random drawing. Now I have a question for you. You pick number 73. What do you do with that slip of paper? You have two choices. You could say, this has been chosen, set it aside. Sampling without replacement. If I do a sampling without replacement, then each time I pull an item from my list, I can't use it again. But I could pick that person, pick that stock, pick that number, and then drop it back in the hat, stir the bowl again. That means I might pick the same stock more than once. Now, if I have this lottery system to draw my numbers, I could have a bunch of dice. I could have a deck of cards. I could have a bingo caller's giant barrel with like the lottery does on TV for the Powerball. Pull the balls, watch them roll down in order, right? You can do this in Excel. There's a random number generator in Excel. The command is rand between A and B. So in our case, we'd write rand between 1, 500. And I'd grab that command, copy it into 30 cells, and it would generate 30 random numbers. But it has no way of knowing whether or not a number's already been generated, right? So that's going to do with replacement sampling. So our Excel function does the second one, which means I am responsible for trying to derive a different way to do the top one. If I want sampling without replacement, every time I pull a random number, I have to say, has it already happened? So that means each random has to check all the previous ones that went before it. That's a little harder to do in Excel. It can be programmed directly. A lot of random number generators used in other places do allow you to do sampling without repetition. But you could do these in all sorts of different ways. Random number generators come in all shapes and sizes. There you go. I rolled my dice. It works. Does it guarantee me no repetition? Absolutely not. But that's the difference between I want you to pick a card from a deck of cards, look at it and put it back and draw another one, versus I want you to pick two cards at the same time. And that makes a difference in the way we count how many things can happen. More on that in a little while. Questions? In one sense, I have made another dramatic assumption here. When we did our random sampling, and I told you I was going to put all 500 of them in a bin and stir it up and pick 30 numbers, you all made the same assumption I did. Every one of those numbers is equally likely to occur. I didn't say that in here, did I? I really should. If I'm trying to do a random sample, I should have it so that each individual thing that could happen is just as likely as each other thing. We call those, surprising no one, I hope, equally likely outcomes, but that isn't guaranteed. I ask you to pick a card from a deck of cards. How many different cards are in a deck? It doesn't matter, you tell me. 52 cards, ace through king in 4 suits. If you add the jokers in, it depends on how many jokers came with the deck. There are usually 2, would be 54. There are some decks of cards that come with 4 jokers for larger games, depending on what you get. So you have to know what sort of set you're working with. Let's go with no jokers. I've got 52 cards. You pick a card. Then you pick a card. Chance you got, how many ways can you get a card? You picked a card. There are 52 choices, right? You picked a card. There are 51 choices. But if you looked at your card and then gave it back, then you picked a card, you'd also have 52 choices, right? If I say I want you to pick 30 cards out of 52 cards, and each one is equally likely, then what happens in later selections is that the chance of getting a particular card is different because of what happened in the earlier cards. So if your sample is a large amount of your population, your later selections aren't truly random anymore. They're a little more biased. And that's actually something we as people doing statistics should try and work to avoid, is a mathematical bias in our selection. Now, please note, you can still be mathematically as unbiased as possible and come up with some really biased statistics using bias, not in a mathematical sense, but in a cultural sense. So I'm really kind of working for mathematically unbiased. So the way we do this is to compare our sample size and our population. So I want that fraction, sample on top, population on bottom, to be small. And I will really work with the idea that this fraction should never be close to 1. The closer it is to 1, the more I might as well just do a census. So when we think of a large population and a small comparative sample, we want this to be smaller than 0.05. If that's true, that our population is 20 times larger than our sample, we've got what is effectively an infinite population. Now, obviously, we're going to want to make samples that are large enough to be meaningful. If I pick 1 out of 20, well, I've satisfied that equation, but one person does not a descriptive sample make. Questions? In spite of the fact that I rolled dice on a computer app, 99% of the computers on the face of the planet do not truly generate random numbers. The algorithms by which your computer generates random numbers were coded by someone. And that means they're really pseudo-random numbers. There's an entire mathematics of randomness separate from what we're going to worry about. But understand that if somebody took the time to map out all the numbers you generated for a sufficiently large sample, they might actually be able to tell which generating algorithm you were using and thus make predictions on what the next number should be. That's hard as hell. It's doable with modern computing technology. And that's why more and more CS people spend more and more time making better algorithms. Back in the late 60s, early 70s, the Rand Corporation, of which there is an office down in Pittsburgh right next to Carnegie Mellon, the Rand Corporation published a standard random number table. It was the second stupidest thing to happen to statistics ever. Because if you turned to page 1 and started generating random numbers, everybody knew what the next one was going to be. So we can say these are randomized, but if you truly want a random number generator, you're going to have to work a lot harder. Most of the time, we use a more systematic sampling method, a non-random or a deterministic method. Somebody said pick every 15th, right? Every 15th. If I pick every 15th, I've gone through my list. Here's number 15, here's number 30, here's number 45, here's number 60, and on and on I go. I've got a system to pick out what I'm doing. When you've got a really large population or a continually being produced population, then this is most likely the way you're going to go about picking a sample. You're going to say, I'm going to take every 100,000th pencil that comes off the line at Faber-Castell, and I'm going to test that one. I'm going to see how strong the wood is. I'm going to test the eraser. I'm going to see how long it writes. There is a machine at, I believe it's at BIC. They take a pen, they stick it in, and it writes. Draws a circle, and they move the piece of paper under it, and it draws this circle until the pen runs dry. So they can tell you how long a BIC pen will write, literally. How long was the line it wrote? You think they do that for every pen? No, it's destructive testing. You can't use that pen anymore. It's dead. But now I have a sample. Maybe I pick every 100,000th. I can get a sample of easily 20 or 30 a day. They make a lot of pens. And I'll test them. And then I can tell you, oh, your pen should write at least 2.2 miles. If I have an arrangement, I can say, okay, all the people on this end of the rows, you're my sample. Congratulations. I've picked a stratified method. I've got some systematic way of figuring it all out. In order for me to make this work, I'm going to need to make sure that I pick enough people to make that fraction work. What if I have a periodic issue? Let's suppose that I say I'm going to measure traffic in the cafeteria every 6 hours. I guarantee you, one of my measurements, the cafeteria is empty, right? Because one of those happens, I don't know, midnight. I know it's a college campus. Maybe I use it at 3 in the morning. I'm pretty sure the cafeteria is empty at 3 in the morning. 9:03, uh-oh, it's 3 o'clock in the morning and nobody in the cafeteria. It's not common, but periodic sampling could be a problem if we have periodically occurring issues. So we picked every case item for some value of k. Again, in order for me to get that size to be small, k should be somewhere about the reciprocal of that fraction. It should be capital N over little n. So, for example, we talked about coffee consumption earlier. I'm pretty sure I can tell you when coffee consumption goes up. Usually it's the last week of September, first week of October. Then it's the last week October, first week of November, and then it's all of December. Why? Here on campus, I know that's when coffee consumption goes up. That's exams. About a month in, about another month in, and then we come back from Thanksgiving, it's finals exam, people. I'm going to be studying all night long. Periodic issue will affect my measure every semester. The one I saw most interestingly was done at Dollar General. Dollar General sees huge spending sprees between the 1st and 5th, between the 15th and the 20th. Why? Weekly paydays. There you go. You get paid twice a month. You get paid on the 1st, you get paid on the 15th. That's when the spending happens. Sometimes a system isn't enough. Stratified. Stratified. What is the word strata or the word stratified? What's that mean? The internet is your friend. Google it. Look it up in the dictionary. What's the word stratified mean?
Formed in or arranged into strata or layers.
Layers. Strata. So strata itself means layers. I want to think of that as groups that are kind of the same. So a layer here would be some sort of uniform, I'll use a technical science word, homogeneous of the same kind. Layer, that's a strata. I could say, well, then what I really want is I want my sampling to go through all the strata. If I pick things at random, I might only end up picking from one layer. If I picked by a system, my system might not equally distribute itself across all the layers. So if I have a stratified population, I'm going to want to do a stratified sample. Measles, mumps, rubella vaccination rates differ by gender. If a population is 55% female and 45% male, I want to take a sample that accurately reflects my population, I should probably want a sample that is also 55% female and 45% male. Or I'm going to have to do some sort of weighting to my sample. So a layer being a group of things that are all similar, then I want to make sure I sample across my layers. Now, I did say something about weights. So I could do a completely random sample. The numbers I gave. My population was 55% female and 45% male. So I do a random sample of 50 people. And then I look at the answers and divide them up by gender. I take all the male answers and all the female answers. And since female answers were 55% of my females were 55% of my population, I weight the female answers by 0.55. I take the male answers and I weight them by 0.45, adjusting my answer groups to match the overall distribution within my population. There is a larger case study in the textbook on page 38. That talks about this a little more, and it talks about stratified sampling behavior. Questions? One particular type of stratified sample that happens a lot is something called cluster sampling. Now, in cluster samples, your strata is usually geographic. So you could say, I'm going to look only at people in this zip code. I could look at different zip codes or look at by school districts, right? And I could say, oh, that's a geographic way. And then I could say, all right, I have 15 school districts in this county. I need a sample of those. 15, I'll use, I don't know, 3. And then that's a large sample. But then I could say, oh, within each of those 3, let's pick some subregions. A school district could be divided across multiple zip codes, or maybe it's the other way around. You could go by blocks, by neighborhoods. If I go to Pittsburgh, there's a gazillion different little neighborhoods, right? Break up all sorts of different ways. But that's 2 staged ideas. School districts, buildings. Who lives in which dorm? So I could ask by dorm, and then I could ask by floor, right? There's strata within that. So I can do different stages. Now, why would you do this kind of sample? Why would this be of any benefit?
You can get more specific in like your search.
Absolutely. There are lots of reasons. What else could be a benefit to doing a cluster sample like this? If I'm doing a stratified sample, I've got to go to each of those different places, right? If my cluster is defined geographically, I'm already there. I'll save travel time, travel costs. That could be more cost effective. And the further I have to go to make sure I'm across all my layers, my costs go up. If I can accept the trade-off between a geographically convenient sample and the different type of stratification I'm getting, this might work fairly well. Regional variance makes this work pretty well most of the time. I have heard, with a lot of discussion about the election on the news, I've heard a lot of people talk about pivotal counties or must-win states, right? That assumes that everyone in Westmoreland County thinks, feels, and votes the same. This is a must-win county for Trump, a must-win county for Harris. I don't care who you're voting for. But that's a geographic cluster, Westmoreland County, as a single ideal data point. If you look at a map from the 2000 election, sorry, the 2020 election, you will see a county by county breakdown of Pennsylvania. You will see 4 blue spots. The rest of the county is red. Philly, Harrisburg, State College, and Pittsburgh were blue. In 2020, that was the election map. But that's a cluster. That's a geographically driven sample. And last time I checked, the state of Pennsylvania didn't decide its votes by county, decided by the state total. So is this valuable? Do a cluster sample for voting? Maybe, maybe not. The Bureau of Labor Statistics, from which I get almost all government statistics that I'm going to use within this class, does a lot of cluster sampling, but they do it in different places around the nation so that they can spread their clusters out a little. They're a government office, though. They have money out the wazoo. So they're less concerned about cost the way that I am. Page 39. Uh-oh. So there's a two-stage cluster sampling. Within this district map, they chose 4 districts, and then within each of those districts, they chose an appropriate fraction of actual entries. So pick 4 items, sorry, they chose 3 clusters and then 4 items within each one. So they got a total of 12 samples out of this. But these are systematic samples. These are, I went through and decided how I was going to do this. You don't always do that. There are sampling methods that are not just non-random, they aren't necessarily systematic. Lots of industries have industry experts that will come in and say, I want to talk to these people. How do they pick those people? Well, they know through all of the other work they've done that those people are typical representatives of the industry. So you could come in and say, well, the people I really want to talk to know how Seton Hill works, I want to talk to the administrative assistants. Then I want to talk to a couple of faculty members. I want to talk to a couple of people on some athletic teams. I want to talk to a couple of people in the music department, a couple of people in the theater department, a couple of people in the science department. But I get those clusters based on my judgment of how I've seen other universities and who knows what's going on. Those are typical representations, but that's a judgment call, and that means you have to have faith in the experts you're putting your money behind. By the way, this includes things like quota samples. I want to make sure I get a good proportion of my sample to be male, a good proportion of my sample to be female, a good proportion of my sample to be minority, a good proportion of my sample to be majority. I need to make sure that that is an accurate reflection of the population at wherever I am. Now, that could be people, houses, buildings, bridges. I keep hearing about the infrastructure bill, especially after the collapse of the Fern Hollow Bridge in Pittsburgh a couple years ago. Fell down with a bus on top of it. They went looking at all the bridges. That's a census. But before that, they had been sampling bridges. How were they sampling them? They were sending out engineers to make their best judgment on, should I look at this bridge or that bridge? How old is the bridge? How long has it been in service? What's the weather like in that area? That's going to make a difference. Who's willing to actually answer my nosy questions? That's a convenient sample, right? I'm going to stand here with my clipboard and I'm going to ask every single person that walks by, hey, do you have a minute? Can I ask you some questions about? And the ones that stop and give me an answer, great. I could do that out in front of the cafeteria and low dining hall. I could do that out on the parking lot, out on E-lot. I could stand at the gate where everybody goes through the park and go, do you have 10 seconds to answer a question? They're going to drive right past me. But where is it convenient? Who's nearby? Who can I ask? It's going to be really easy for me to ask, for you to ask your neighbors in the dorm, your teammates in your team, your classmates within your class. That's a convenient sample. There's more. I've got exactly 30 seconds to tell you about this, so I'm going to wait and we'll do more on Wednesday, not Monday. Have a lovely extended Labor Day weekend. I will see you all on Wednesday. I've got more through a couple more sections on our Canvas page. Please note, I did post some of the examples from Wednesday. You'll have more examples posted from today. If you came in late, please come sign my paper. And on Wednesday or Friday next week, we're actually going to try and make a seating chart so I can do without sending this around.